Hello all, welcome to OFA Studies YouTube channel. This is continuation to AI agents playlist. In this video, we will be discussing about how to implement multi-agent solution using semantic kernel. So I believe that you are following all the videos in the playlist, which is Develop AI Agents playlist. If not, please watch them because this video will be continuation to it. Especially in our latest video, we have discussed about what is semantic kernel and using semantic kernel how to implement or develop AI agents. Okay, so I'm not going to details about AI agents. I think by this time you know it. So let's directly jump into the topic of this video. So generally, in some situations, you might need to deal with larger than realistic issues. So what that means is for a single agent to accomplish that task, it may be very larger. So because the whole task might be like a combination of a couple of smaller tasks. So in such situations, ideally we should be considering developing multi-agent solution. In multi-agent solution, what will happen is multiple agents will talk with each other and perform a task. Let's assume agent 1 is responsible to finish the task 1. Agent 2 is responsible to finish the task 2. So task 1 and task 2 combinedly is your full task, the overall task. So here two agents we are using it to accomplish the multi-agent scenario. So in such scenarios, we need this multi-agentic approach. So we are going to discuss that using semantic kernel. So the real-time example for this is imagine a Devops challenge where generally what will happen is ideally there will be always a need to monitor the application performance. See how the application is performing. If something is not going well, identify the issues, and if based on an issue, deploy the fix for it. So that way you will be continuously monitoring your application performance and fixing an issue on a fly. So let's assume you want to achieve that using this multi-agent scenario. Because if you see here, right, this task has a multiple task in it. So one is monitoring. So you need to monitor the logs. Maybe for that we will have something called monitoring agent. Then you will be identifying a root cause of it, right? So maybe another agent will identify what is the root cause by understanding that logs, whatever it is available. Then once the root cause is found out by a root cause agent, then a automated deployment agent from DevOps side will spin up and it will fix the issue, fix the root cause issue. So that is called automated deployment agent, right? Then finally a reporting agent that will kind of like a detailed summary of anomalies, fixes, and all these things. So if you closely observe, there are more than one agent. Around four agents were involved in this whole complete task, right? So in such scenarios, we have to end up with creating the group multi-agent scenarios. So how multi-agent scenarios will get implemented in semantic kernel? So that's what the main idea of this video. So I wanted to introduce you with couple of classes and methods in semantic kernel that will help you to accomplish this. So there are and many other ways too, but we will be focusing of few specified classes in semantic kernel which helps you to develop this multi-agent thing. Okay, so now there is something called agent group chat. Okay, so what is this agent group chat is so imagine we as a humans we all use WhatsApp, right? So we will create something called a group chat there, right? So more than two people wants to have a conversation or more, then we will be adding a group chat there and everybody will talk with each other. And even though person A, person B talking with each other, person C also knows what is happening because person C is also part of that group chat. So same example, if you apply into this agentic world using semantic kernel, if you want to accomplish the multi-agent solution, first thing is you can go ahead with creating the group chat. So there is something called agent group chat class. This class allows you to create a group chat, basically a chat object that will help agents to talk with each other. So when you are creating that group chat object, agent group chat object, you need to provide the agents to it. So let's understand a scenario where there is a writer who writes some slogans and there is a reviewer who reviews it. So writer agent we have to create, then reviewer agent we have to create. So these both the agents we can pass it as a parameter to the agent group chat constructor and create the chat object from it. That is one way. Or another way is you first create the group chat object, an empty object, and use add agent method on the chart to add your agents. So in this scenario, there are two agents, so writer and reviewer. So I am adding both. In real time scenario, you may have more than two. So you will continuously use this chart.add agent function to add the agents to the group chat. So once the agents get added into the group chat, then what is the next task, right? So next task is you need to add the chart. You need to start the conversation in the group chat. You need to add the chat messages to it. Okay. So how to add the chat messages? So there is something called chart message content class. So this class helps you to create the chart messages, and that chart messages you will add it to the group chat. If you see this code here, so I am creating a chart message content class object where I am passing the message, and also I am passing the role, assume that like this is like a user input, right? So this is like a starting point or the first message to the conversation in the group chat, and that chart message we added on the chart object which we created above. Okay, so this is fine. So we created a group chat, we added agents there, we added a chat message into it. Now the how the conversation will happen. So in group chats, conversation will happen in two ways. There is something called singleton conversation and there is something called multi-ton conversations. So the difference between, as name says, right, singleton conversation means single agent will respond based upon the input provided to it. Okay, and there is something called agent group agent group chart that invoke function. That function help you to invoke the single agent. You can define which agent to invoke also. The example what you see here, the chart dot invoke function. This chart is a agent group chart object only, right? If you remember from here, so it is a group chart object only. Okay. So on that group chart object, there is something called invoke function to which I can pass the agent which I want to invoke. So this is called a singleton conversation. So I am explicitly invoking something to get a response back, and whatever the response comes, it will come into this message, and that's what we can process below. Okay. Now, when you come to the multi-ton conversation, obviously the same invoke function will help you to do that, but you don't specify which agent, okay? Because the system automatically takes the agent depending upon the strategy what you defines, and multiple it can involve not only single agent, it can one after another. It may involve other agents too. So that is the reason it is multi-ton conversation. Okay. So all this is theory for now, but understand this, guys. So there is something called agent group chart. On top of that, you will add a chart message, and there is something called invoke function on the agent group chart that will help you to invoke the agents. So far, this is what we have discussed. And the very important thing is in this group chart mechanism, the selection strategy. Sometimes the agents you don't want to execute in a sequence, so this selection strategy help you to define a strategy in which order agents should get invoked. So there are two classes available. One is sequential selection strategy and second one is kernel function selection strategy. So using either of these classes will help you to define a strategy. Okay. So in our example in this demo, I will be showing sequential selection strategy. But for the theory purpose, I am going to quickly give a rough idea about kernel function selection strategy too. So what is the sequential selection strategy, right? So as name says, it will make sure to execute the agents in sequence order in some predefined order. So if you and that is like a default behavior also. Okay. So it's a predefined selection strategy where agents will order one after another. Okay. So ideally for example, if you see at the top right, so the way we added agents into the chart in the same order they will get executed. So for example, if you see here, right, the agents got first agent got added is a writer and second one is a reviewer. So in the same order, so first writer will go, then reviewer will go. So that is the way the order of execution will happen in the sequence selection strategy. Okay. And there is something called kernel function selection strategy, where actually like you can write a kernel function using a prompt. So like how you see a prompt here, right? So you can define, okay, in this situation take this agent, in this situation take that agent, this is the way to execute blah blah blah. You can define the whole prompt. I mean, in natural language you can tell your strategy, and that strategy will be adapted by semantic kernel to invoke the agents accordingly based upon the input and output responses. Okay. Uh, Now selection strategy is fine, and always there is also one important thing is termination strategy too. So whenever you open a group chart, it makes sense that sequential order or random order, whatever it is, how the agents should get select, that strategy is important. And similarly, when to end the conversation, when to terminate the conversation. So even that strategy is important. So that is called termination strategy. If you don't provide the termination strategy, then basically the conversation will keep on go and it will go maximum up to 99 iterations. Okay, so there is something called maximum iterations parameter. For the termination strategy, we can define that maybe three iterations are enough. My job will over, so I can define that maximum iterations. Accordingly, the termination will happen. And also after which agent I want to terminate, after what kind of a message I want to, or what kind of a response I have to terminate. So all the details we can you can implement this chart termination strategy class, and you can define it there. So in our example, it is there. I will show you that. Okay. So default termination strategy class will only terminate after the specified number of maximum iterations. That means if you don't provide any termination strategy, so by default it will terminate only after maximum iterations, that is 99 iterations only. Okay, the same termination strategy can be achieved using the kernel function termination strategy also. Again, here you will write a prompt for your termination strategy and it will get adopted by your semantic kernel framework. So this is a theory part. So this is very important to understand. So next I will quickly show you the example also. So just to recap for 1 second, 1 minute is so for multi-agents you need to create a group chart. Okay, and in the group chart you will add agents. Okay, and also you will add a chart messages to it. And how the group chart should happen, you need to define the selection strategy, like how the execution should happen, which agent should go, blah blah blah. And also there is something called termination strategy, when to terminate the agent's execution. So you need to define all these classes, then you can achieve that group chart of agents to achieve the multi-agent solution. So now for the demo, I am going to use there is something called assume that there is something called incident manager object sorry agent that will go through the logs and understand what is the issue. Okay, then once the incident manager understands the issue, assume that there is another agent called DevOps assistant that will fix that issue. So assume that these two were agents were there, and there are a couple of logs available in a system. So every log file has to be analyzed by incident manager agent to see what is the issue, and then it should create an issue, and the DevOps agent should go and fix that issue. And once the issue get fixed, it should move to the next log file. So that's how I want these two agents to talk with each other and implement the whole solution of this multi-agent for this example scenario. So how that will look like, I will quickly show you that. So all this code, whatever you are seeing on this screen, is available in my Visual Studio 2. I will quickly show you that, and I will provide you this code in the description of this video too. Okay. So, but firstly, if you see, if I go to this chart agent underscore chart file, so I'm not going details about how to create an agent, all that things, because in my previous videos I have discussed. And one thing I forgot to say is, so this whole code will be available even in this GitHub repo too. Okay, so you can take it from that repo too actually. Okay, so I will provide the link of that also in the description of the video. So let's understand this code. So firstly, there is something called requirements-txt file. So Python dot env package, semantic kernel package, Azure identity packages. You have to install it. We were installing these packages continuously from the previous videos. So I assume you guys know it. And also you have, so now I am going to create a agent, these two agents in my Azure AI Foundry. So that means I have to authenticate to my AI Foundry and create agents there from my code. So I should give my Foundry endpoint and also the model name from my Foundry. So even these details were there in my past videos. So you will know that when you are, if you have seen my previous videos. So I have a .env file with my AI Foundry project endpoint and also a model deployment name. And also I have a requirement.txt file where I have a packages. So what I will be doing it, I will going I am going to terminal and create a new terminal. So you need to just install this requirement.txt file packages, and to install that I think we all know that pip install -r then requirements.txt file. So that should install all the packages for you. Okay, so I have already did it, so I'm not going to do that now. So now let's go to the and if you see there is a logs folder, so I have four log files here. So if I go to the log1.log file, if you see here, right, some service X is running in my background and which is generating these logs, and I see there is some failure here. So now incident manager should understand this failure and create a issue. Then DevOps manager should come and fix that issue, and then tell the response back that system is up and running, right? So similarly, I have a couple of logs here. So this is like a transaction processor, and this is for a API manager. So I have a couple of logs basically. Now, if I go to my chart, let's understand like how that whole implementation happened here. Initially, yes, have all these libraries imported for you, and if you remember the termination strategy and the sequence selection strategy, that's what I'm going to demo in this video. All the details were there here, and agent group chart. So these all classes we are going to use it. So firstly, see, I'm creating two variables, one to hold the agent name incident manager, second to hold the instruction to the agent, like what that agent will do. This will analyze the log file and response back to the DevOps agent, blah blah blah, all the details like what incident manager agent should do. So two variables. And similarly for DevOps also I have two variables. One is to hold the agent name, second one is to hold the agent instructions. Then I have something called main function. So let's keep that aside for now. See, I created two things. So assume that we have two agents here. So we haven't created it. We just composed the agent names and descriptions. So I created a selection strategy, and also I created a approval termination strategy classes. So these classes were already available in semantic kernel. We are extending these classes with our own implementation. So in the selection strategy, so I am using something called select agent function. We are overriding this function. This function helps you to select a specific agent after every iteration. And if you see here, we are getting all the agents into this select agent function, and also the history of the responses in a particular conversation. So we are saying if it is a DevOps agent or the user who responded, then incident manager should go. Otherwise, DevOps assistant should go. So this is the strategy which I defined based upon the order of the previous execution of the agents. Okay, a simple strategy. Now, when it comes to the termination strategy, so what I am doing it here, should the agent terminate? There is a function that if it is a true, then it should terminate. If it is a false, it should not. So when I am making it to, or when I am returning true, if my response, if my previous response in the chart history is no action needed, then yes, I mean that means DevOps assistant agent fixed the issue and process is running back. So you won't see any issue now. So that's where the conversation should end. So after DevOps, incident manager will come and check it, and there is nothing. So incident manager will say everything is clear, no action needed. The moment that message sees, the DevOps agent will stop the execution there, the terminate the execution there. And this is like a DevOps plugin. I think you guys know it from my previous video in semantic kernel. The functionality, what you have to achieve, you have to create a plugin class. So please watch my previous video. So for DevOps, one plugin class they created, and for processing the log file, another plugin class. And here we are not doing, we are simply reading that logs files and giving the data back and basically giving the issue back. Okay, and if you see the DevOps plugin, basically I mean don't think it is actually going to the DevOps system and fixing an issue. So it will simply print some messages or add some messages into the log file that in turn tells that the issue got resolved. Okay, so but assume this plugin has a functionality to actually hit a DevOps, so assume that way. So I have a couple of functions, restart service. If incident manager says restart service needed, then this will get invoked. Rollback transaction. Based upon what incident manager identifies an issue, a different task will get executed from here in the DevOps, and it will fix the issue. So all this is fine. So we have agents maybe, and we have the selection strategy and termination strategy. And so let me minimize the termination strategy and then the selection strategy. So we have both. Now, what actual implementation in a mind? So what we did, firstly we are clearing a console, and then we loaded the agent settings from the .env file. Then here we created Azure AI agent client. It's basically a project client class object. That means when I say project clients, AI Foundry project client. Why we need AI Foundry project client? Because in the AI Foundry only we are going to create the Azure AI agents, right? So then we are creating a agent here. We are giving the incident manager variable value as a name, instructions back to the instruction parameter. This will create a AI Foundry agent from here to here. So now that AI Foundry agent what we created is that is cool. On top of that, we need to create a semantic kernel agent also, because we need to attach the plugin functionalities what this agent has to achieve. So if you see, when we are creating a semantic kernel agent, that's where we are attaching a plugin. So on top of, using Azure AI agent, the same AI Foundry agent what you created, I'm using it here as a definition and adding a plugin function to what this agent should do. So this is like an actual semantic kernel agent. So this agent is the same agent but in the AI Foundry without tool or without plugin. So we created a agent for the same thing by adding a plugin functionality or a tool functionality. Same goes with the DevOps agent, also created a AI Foundry DevOps agent, then create a semantic kernel DevOps agent. So then finally we are opening a group chat as I said, and in the group chat for the agents parameter pass both the agents incident and DevOps. So if you observe the order, I am firstly sending the incident, then DevOps, because I want the order should go incident to DevOps, then again incident to DevOps in that fashion. Then termination strategy, the same approves termination strategy class what I have extended. So in that what I have wrote here, so it is almost the same. If you see here, right? I mean whatever the logic I have written here, right? So it is encapsulated in this class, right? So I am simply calling that class, and to the class I am passing my agent, incident agent, because after incident agent only whatever the message comes, that's what you want to monitor. If the message says no more issues, then terminate the execution there. Then maximum iterations 10, so more than 10 iterations don't go. So we are setting all the parameters for the termination strategy. Then selection strategy, again the same selection strategy class object what we have created it. But remember, this selection strategy and approval termination strategy, these are not like I created a classes, these are available in semantic kernel. I am extending those classes. Okay. So once we have that, so now I am writing some for loop here to process each file, each log file one after another. But if you remember the chart message content, we have to create a chart messages first. So I am creating a chart messages first with a location of the log1 file or log2 file or log3 file. And that's what we are passing it into the group chart. So once user input happens, then immediately as per the selection strategy what we have defined, incident manager will come, then DevOps assistant will come to fix it. Again, incident manager will come and says no issues, then the termination will happen. So if you see here, the chart.invoke function gives you back the response. That's what the actual response. So we get that response asynchronously and we process it below. Okay, so very simple execution. So always remember the main takeaway is group chat object, then add agents to it, termination strategy, selection strategy, these are the things. So let's run this and see. I installed all the necessary packages in my virtual network, my env. So let me activate my virtual network using this command and let me hit enter. So now here, so I CLS, so I will try to run my file python agent.py file. The moment I hit that, it will create a group chart object, selection strategy, termination strategy, and everything. And user inputs go and execution will start there. So user input here, right? If you see here, so I created a chart message content here with the user, then this greater than symbol, then the location. With that process will start and one after another, incident manager, then the DevOps assistant will get invoked and it will move. Okay. So if you see the execution, it is getting a log files. Let's wait for the execution to actually kickstart and get the log files. You see here, it processed the log1 dot log file, and the incident manager actually identified there is an issue. We need to restart the service, and the DevOps agent came automatically. I haven't done anything, and it resolved the issue. Okay, and incident manager again checking the same log1 log file. and it says there is no action needed. And if you remember in our termination strategy, the moment we hit the no action region, see in the termination strategy, the moment we hit no action needed, that's where we have to terminate the conversation there. That means for the log1.log file execution will pass there, and it will eventually move to the log2.log file. Because it is the whole thing is in a for loop, if you remember, for this file structure, right? So that is the reason. So now if you see, it is processing the log2.log file, and as you are assuming, the order will go incident manager first, and it will do the processing, identify the issue, then it will hand it over to the DevOps. See, incident manager identifies an issue, maybe rollback transaction, then DevOps assistant is fixed that issue. Okay, assume that way. So transaction got rolled back. Okay. So then incident manager will go check the same log2 file and no issues. Then it will terminate the execution and move on to the third log file. So this way, this whole execution will keep on go until log 4 because I have 4 log files. So that's how using the group chart objects and selection strategy, termination strategies, we can achieve the functionality of a multi-agent using a semantic kernel. So thank you for watching this video. I hope you find this video helpful. I will give all this code in a video description. Please take that code and try it by yourself. Thank you everyone for watching. Have a nice day.